We're going to be talking about compound inequalities in this section. A compound inequality is a little bit different than just a regular inequality because it means that there's more than one inequality in the same problem. So let's take a look at these examples. The first example, we're just going to read this statement and then we're going to try to graph the inequality or the compound inequality that is expressed here. It says all real numbers that are greater than -2 and less than 6. So if we draw our number line out like this, let's see, we're starting at -2. We're looking at all real numbers greater than -2. So since it's greater than -2, I'm going to put an open circle at -2. It's not equal to -2, they're greater, so my line's going to go to the right. But all of our numbers also have to be less than 6. Well, here's 6, so I put an open circle there. Less than 6 goes this way. So the key phrase, or the key word, in this phrase is and. We have a number that's, we want to know all the numbers that are greater than -2 and less than 6. That would be all these numbers here that are in this shaded area. Now there's also another way to write this. We can write an equation where we can call this number in here x. So we can say, actually let's start with x first. We say x is greater than -2. X is also less than 6. So the inequality statement would be -2 is less than x, which is less than 6. Or you can read it backwards. 6 is greater than x. X is greater than -2. Now, there's one other way to write this. This is called interval notation. Now, this is probably something you have not seen before. In interval notation, we use symbols that are either going to be brackets or parentheses. I don't know what you want to call those. One side of a parenthesis. And here's how we do it. We put, if it's an and statement, which that's all you know so far, our next example we're going to use the word or. But for right now, the and statements, you look at your first number and your last number. So all our numbers are in between -2 and 6. So we write -2, comma, 6. And then we're either going to put a bracket or one side of a parenthesis on either side here. Here's how you know. If it's an open circle, you use the parentheses. If it's a closed circle, use the bracket. So with the -2, it's an open circle, so I'm going to put a parenthesis there. The 6 is also an open circle, so I'm putting a parenthesis there. And that's the interval notation. Don't get that confused with graphs on a coordinate plane. This is interval notation, just another way to say this here. The next example. All real numbers that are less than 0 or, keyword, greater than or equal to 5. So the best way to approach these problems is take them piece by piece. So we're looking at all real numbers less than 0. I'm going to put a 0, start there. And then we know we're going all the way up to 5. Okay, all real numbers that are less than 0. So this is an open circle because it's less than. It's not equal to, it's less than. So we have an open circle, but all the numbers are less than 0. That's going to the left. Or greater than or equal to 5. Greater than or equal to will give us a closed circle at 5. And greater is to the right. So our graph in this case, we're saying all numbers that are less than 0 or all numbers that are greater than or equal to 5. So all the numbers are included except for 0 all the way up to 5, but not including 5. Now let's write equations out for this. Not equations, sorry. Let's write inequality statements out for this. When you're using or instead of and, you're really just writing two separate inequalities. So you're going to have 0 is greater than x, and then you're going to have or 5 is less than x. Now you can flip those if you'd like so that it reads x is less than 0 and x is greater than or equal to 5. Forgot my equal to sign there. That's what makes it closed. It says greater than or equal to. So there's a couple different ways you can write that. Now using interval notation. This is a little bit tricky. But watch what we do here. Since it's an or, we're not going to just have one set. We're going to have two sets of either parentheses or brackets. Okay, we start from the left. What number is all the way to the left? Well, this goes on forever this way. So this number is infinity. We write infinity like a sideways 8. And actually going this way is negative infinity. So we call it negative infinity. And our answer goes all the way up to 0. So all the numbers from negative infinity to 0 are included. Or we have all the numbers 5. And notice I put a bracket here because this is a closed circle. Closed circles get the brackets. From 5 on forever to the right, which is positive infinity, which looks like that. For second example, we're going to solve this compound inequality, or simplify it. Right now we have negative 3 is less than or equal to n minus 4, which is less than negative 1. You want to pay close attention to what we do here. Locate your variable in the middle. You want to isolate the variable in the middle. This is a compound inequality using the word and. So you're going to have this long inequality with two symbols in it. Now we're going to solve for m. We have m minus 4. So we want to eliminate minus 4 and we're going to add 4 to this. But watch what you do here. We're used to just adding 4 here and then adding 4 one more place. What we're going to do is we're going to add 4 to both of the other sides. So we're going to add 4 in the middle, we're going to add 4 on the left, and add 4 on the right. Now we get negative 3 plus 4, which is 1, is greater than or equal to just m. And then negative 1 plus 4 is 3. So our answer is 1 is less than or equal to m, which is less than 3. Now to graph this, have a closed circle at 1, and m is greater than 1, so it's going this way, and an open circle at 3, and m is less than 3. So that's what our graph looks like for this compound inequality. Now to write the interval notation, we would have brackets for the closed circle and a parenthesis for the open circle, and our numbers would be 1 and 3. This is interval notation. Our next example, it's a compound inequality using the word or. So it's just kind of like having two problems. And this is like a a two-step inequality. We have 3m plus 2 is less than negative 7. So we're going to subtract 2 from both sides. We get 3m is less than negative 9. Divide by our coefficient 3. And we get m is less than negative 3. Or, and we need to solve this one. We're going to subtract 5 from both sides. We have negative 4m plus 5 is less than 1. We subtract 5. That leaves us with negative 4m is less than negative 4. Divide by our coefficient, which is negative 4, and we get m is less than negative 4 divided by negative 4 is positive 1. Now one thing we need to do is, since we divided by a negative 4 on both sides, we need to flip our inequality. So this inequality now changes this direction. So our answer is going to be m is greater than 1. So how do we graph this? First thing was we have m is less than negative 3. So if negative 3 is here, an open circle, m is less than that, so it's going to the left. And then we're going all the way to 1. And m is greater than 1. Another open circle, greater than 1. So a lot of times what you notice is with the or statements, your arrows are going to go in opposite directions. With the and statements, which it doesn't say the word and here, but when they're all together, that's and, you're going to have your arrows going into each other, which is just going to create like a line segment. Okay, interval notation. This is the hardest kind when they're going out away from us. So we're going to have two sets of intervals. Negative infinity always on this side, and if you want to just put infinity on that side, it's always going to be the case. Then we have negative 3. This goes from negative infinity all the way to negative 3. And then we go from 0 all the way to infinity. And notice they're all parentheses, no brackets, because they're open circles.